Hey guys, so in this video we're going to show you how to do all the equations and figure out all the different things you need to know for a parallel circuit. So the first thing I want to do is I want to talk about what is a parallel circuit. So a parallel circuit is pretty much a circuit that has more than one place it could possibly go. So again, we're going to start by drawing our battery. Not a good battery again, huh? And we're going to have it come off just like we were doing the series circuit, except at a certain point it's going to go and kind of turn, and we can throw in a resistor or a light or whatever, and that's going to make our series circuit. But we wanted to make it parallel, so it's going to actually continue on, go down to another resistor, and then come back. These are actually connected. All right, so this is going to be our parallel circuit that we are going to be working with. Now, it is possible to have 3 different parallel strings, and they just keep adding on, or 4, however many, until you have no more room left, okay? The beauty of a parallel circuit is if like this light bulb goes out, it doesn't damage anything about these other 3. So this would be the one that you'd wish all your Christmas lights was made out of, because remember, this one can go out and the rest will keep lighting up. So a few things that we do need to remember is our Ohm's law triangle. And you might get used to just drawing this thing out for practice. It's going to be V over I R, all right? So we're going to be using that when we come down and we need to find our voltage. So once we have our resistance, all right? Now, then we're going to add in a new equation, and I promise you this will probably be the most difficult we will do, all right? So what it is it's going to be each resistor, and we'll call these ones R1, R2, and then R3, and then we'll even do R4. All right, so how the equation will look, and it changes depending on how many resistors you have in that parallel circuit. So we're going to have R1 divided by 1 plus 1, or 1 divided by R2, just wrote that one different. Then we're going to have 1 divided by R3 plus 1 divided by R4. And all of those combined are going to equal our RT, which is resistance total, okay? So what we're going to do now is we're going to go through and we're going to actually work this problem. Okay, so what I did is I just redrew this up higher. That way we could work in this area right down here and we can start that equation. I did a 3 resistor parallel circuit. If you wanted to do 5 resistors like we had talked about, or 4 or 5 resistors, all you do is you just keep adding on and just keep making it bigger and bigger. Okay, so we're going to go ahead and we're going to draw it out, and we're going to assume each one of these is 5. Let's say 5 ohms. So we're going to go ahead and draw the first one, and we're just going to, everywhere that it had R1, we're going to put 5 ohms. So over 1 plus 1 over 5 plus 1 over 5 ohms. And remember, that's going to equal our RT. All right? So this would be the equation if we were going to be doing this one with all of those being 5. Okay? So the first thing is, what's 1 divided by 5? Well, the answer is 0.2. So now all we're going to do is we're going to rewrite this equation. So it'll still be RT equals 1 divided by 5 was 0.2 plus 0.2 plus 0.2. So we're just going to add those all together, and we're going to have the total for the whole circuit, which would be 0.6 ohms of resistance for this whole circuit. This area from here to here is that many ohms, okay? I hope you can read that. So let's go ahead and let's work another one really quick. And we'll just go ahead and we'll erase that. Okay, so now let's assume that this one is 3 ohms, and I'm just going to write that mainly for my reference, 6 ohms and 7 ohms of resistance for each one of these circuits, or for each one of these resistors, all right? So we're just going to go ahead and we're going to rewrite the problem plugging in those numbers, and we're going to try to work it from top down for you guys. Hopefully that makes it a little easier. RT equals 1 divided by R1, which we're going to put 3 ohms in there, plus 1 divided by R2, which was 6, plus 1 divided by 7 ohms, okay? So we're going to go ahead and we're going to quickly work those. I'm going to punch them into my calculator, and we're going to rewrite this problem really fast. Okay, so now all I've done is I've rewritten this equation. Now, remember, 1 divided by 3 was 0.33. I just took it to the second decimal. Pretty much if you're working on something that I've done, I only take it to the second decimal. Maybe if you're in a test or something for a job, maybe you will take it a little bit further. But for me, that's far enough. 1 divided by 6 was 0.16. 1 divided by 7 was 0.14, okay? Now all I'm going to do is we're going to quickly add these things up, and then we're going to go ahead and we're going to see what our total resistance is. So we got 0.33 plus 16 is 49. Now 0.49 plus 14, which is 0.63 ohms. Awesome. Okay, so now this would be our answer. So now you're more than likely going to get some of the ones like you've done previously for the series circuit, where I want to know what the amps is for the circuit. So what we're going to do is we're just going to say this is 24 volts here. Hope that's a V. I promise it's a V, 24 volts. And we're going to take that 24 volts, divide it by 0.63 ohms to find our total resistance. Remember going back to this Ohm's law triangle right here. So we're just going to punch that in the calculator really fast. And that will equal 38.09 amps. Oh, that was bad. Am. Okay, so that might be a typical question you're going to see coming up here in a second, and it will definitely be on multiple tests throughout this course, okay? This is a very important thing to learn because it's on a lot of entry exams and things like that. So it's a great indicator that you have some electrical knowledge, okay? So that kind of wraps up everything for a parallel circuit, parallel circuit. Like I said, if you see multiple resistors, maybe more than 3, all you do is just keep adding on. You go plus more, plus, just keep adding on, okay? This is like infinite. You could make it huge. So go ahead and work the problems, and then moving on, we're going to do combination circuits, which are just series and parallel together. They're easier than they sound, I promise.